And I have with me Akhilesh, and we'll be like talking about the Dockerization experience at Freshdesk. So it's been a kind of a learning experience for us. We are not experts, but whatever we have done and our journey so far, we'll just talk about it. So quick introduction, I am Subhash, technical architect at Freshdesk, and the last project that I worked in Freshdesk is the marketplace. So recently we launched the developer tools as well as the marketplace for app development and extending the Freshdesk functionality. So I was the tech architect there, and currently I'm kind of doing a consultancy role within Freshdesk where the Dockerization effort in multiple teams. I'm trying to like support them and help them. And we have Akhilesh, who's the platform team, and he's a product developer. A quick intro on the tech background of Freshdesk. Are you guys able to hear me? So the tech background. So as some of you might know, like Freshdesk, we started almost 6 years back, and started as a monolithic application, a huge application in one GitHub, one repository. And around 2 years back, we actually started like partitioning our monolithic application into smaller microservices. And newer projects, they are primarily moving on to the microservices model. And we use AWS. So some of the AWS technologies that we use, I'll be talking about in this talk. The basic agenda is why the rationale for choosing Docker and how we have implemented it. Not a very kind of deep dive, but I'll be telling about the technologies and how we used it. One thing is we have still not deployed Docker in production. So we are actually trying to do it in like phases. And one of the projects that I am working on, it is in staging stage, and we very shortly will be moving to production. So I don't have any metrics on how the platform is functioning in a production kind of environment. Probably in the next Docker talk, I'll have some data on those. So this is the kind of normal software lifecycle: design, code, QA, DevOps, and Docker has kind of impacted in almost all these areas: design, DevOps, or coding, or QA. So it has impacted. It's kind of a thing which has spread into multiple areas. I'll be talking about design and DevOps, and Akhilesh will be talking about coding and QA, how it has benefited. So many of you might be thinking like, okay, Docker is, what is Docker? Docker is basically a containerization mechanism, and it's more of a DevOps thing. But from the point of view of a technical, like an architect who's designing a large-scale system, does it have an impact in the design thinking? It actually was a kind of a revelation for me because before Docker, my thought process was constrained about certain costs associated with hosting. Got introduced to Docker, it was just amazing to see that constraint moving away from my mind, and I was able to like design purely from the domain perspective.
So mostly when we get rid of infrastructure.
Pardon? It's about the design thinking. When I am architecting a new ecosystem of services, should I partition this into a small microservice? A particular microservice might be actually like having an occasional traffic, probably a request per second of 1 or something. For that, should I be provisioning a complete infrastructure with HA load balancer? So these were the cost constraints which used to come into my mind, and I used to think, okay, should I combine that microservice with another existing one, which is a kind of defeating the domain-driven model of design. So this is how my initial design used to be, like each microservice having its own ELB. The trouble with this design is every time I partition something into a microservice, we used to think about hosting it into an ELB and 2 EC2 instances for HA, and the same infrastructure in the staging environment. And the cost would be like kind of prohibitive if we had gone with this kind of model. So, we we are kind of evaluating now ECS, EC2 Container Service, which is a AWS hosted service. So ECS, what it does is it allows me to host multiple containers in one EC2 instance. And for each container, microservice 1 and microservice, I'll be mapping one ALB. This is how I am doing the current architecture. And this has substantially saved us cost, and it's also saved me from from the architect point of view, like when you're designing something, you have this daemon sitting about you telling, oh, if you're bringing out a new microservice, you have to incur this cost and you'll have to be accountable for that cost. Now with this model, I don't have that sitting in my mind and acting as a constraint in my designs. So I'll be totally able to design purely from a domain perspective.
Running a container, microservice in a container, or running a container as an individually, what makes a difference? So if even in EC, let's say in EC2 instance itself, you can have 2 microservices as running as part of it if you have a significant amount of consumption or processor, everything. So how it helps you when it comes on running on a container and running without a container?
Yeah, that's an excellent question. The question is basically do we need container to run 2 microservices? Can we run the container in one EC2 instance, right?
Yep.
So we initially went to that model. So we used OpsWork extensively in Freshdesk, and what happened was, I don't know how many raise of hands. How many have you used OpsWork? Chef scripts?
Sure.
Okay. So the trouble, what OpsWork is modeled with certain functionality for deployment, etc., and we had to manage using OpsWork Chef script multiple applications. It became a very big headache because we had to override the functionality of deploy, and we had to write custom Chef scripts to deploy multiple applications. Okay, that became a hindrance for us, using OpsWork to manage multiple applications without container. That was one hindrance. The second hindrance was about as we evolve in microservices architecture, we started with the Ruby on Rails, then we moved on to Node.js, then we moved on to Go language. So each microservice is having its own programming stack. 2 microservices probably I'll be supporting in the base EC2 instance multiple programming stacks, which I don't want to do. So these are the 2 limitations that we saw. So this architecture is currently in staging, and we'll be shortly going to production with this architecture, and we will get to know about how we are performing in production, and probably that would be a later talk where I'll be able to share some metrics on the production statistics.
We also evaluate
No, we are from kind of this one AWS shop. So we didn't evaluate multiple things. We know about Kubernetes and Mesos supporting Docker hosting. We do not want to manage the underlying infrastructure. So this is an experiment, and if we fail in this or if we find any issues, probably we might look into the other aspects.
Sorry.
Yeah.
So when we talk about the cost, do we say that because we have moved our infrastructure to AWS that the cost thought process is gone, or is it because the containerization made you to go away from the cost perspective?
The containerization, the ability to deploy multiple containers in one EC2 instance, that actually helped me in having that constraint of cost affecting my thought process. So that is the thing. It's about hosting multiple applications in one EC2 instance. So if you see the pattern of applications that we have in Freshdesk, some applications are receive heavy traffic. They are transactional, they receive the traffic. Few microservices, if you see, they are so what to say, they are heavily cached at the consumer side. Okay, so they get very less traffic, and for that kind of microservice, just to have HA, should I be like setting up a separate infrastructure like this? So that was the big question for me. Or should I be like combining all those small microservices which don't get so many traffic like hits? Should I be combining them and hosting it in this mode? So this was the prime criteria that we had.
What would be the advantage if I host a VM instance on EC2 and then up and some microservice inside of VM? So will you get any benefit over it?
You don't get any benefit. You get only disadvantages. I feel that if you use more hypervisors, you use more efficiency, right? I think level of abstraction, indirection, you lose like memory throughput, the network throughput, everything. So that would be worse than using containers.
You're having a limitation of resources. The moment you start using multiple VMs rather than having a common hypervisor and having a container on that. So it is, see, Docker itself is like not a replacement for the LXC, the Linux container that we had. It's just rather than having a VM running, you're running a container, but that is running on a common hypervisor. That makes a difference, and a huge difference in terms of the resource sharing.
So has this been tested? I mean, do you have any evidence or any performance? Have you done the performance testing or anything that?
So the strategy we are adopting is we are taking a very less microservice which is going to like have RPS of one request per second kind of microservice, and we are going to like go to production with that microservice. We are not yet gone there. Go there, only then we will get to know about how it is performing, etc. By looking at the community, we saw that they have mentioned about few issues like the ECS agent getting crashed pretty often and all. We have not seen that kind of incident happening in our staging environment, but we will have to see. Like production, we'll have to go and we'll have to wait for some time to get the metrics.
So you have done the regression testing on a live data or like some plot?
So this particular project that I'm talking about, we don't have extensive testing. It's just the unit testing part, which is done by the developers, and we will be like going live with that.
The reason why you actually went for 2 EC2 instances and going, having 2 containers is the reason of saying like a performance, right?
About performance, it's about the flexibility I get in the cost benefits that I get.
Apart from cost, like performance is the additional thing that you
No,
want.
performance I will not be getting. So that is what I'm actually worried about. Be adding obviously some latency or something. Inside the EC2, I'm adding one more layer and then I'm executing my app above that. So we don't know about that cost associated, and we need to evaluate that. That is when we need to like go to production, see how it is behaving, and we need to collect the metrics.
As for like the performance difference between a virtual machine and a container for hosting applications, there is a study from IBM. It's a control study where they like evaluated the performance of MySQL or like some derivative of MySQL, and they found like 2x performance improvements in network throughput, network I/O, disk throughput, and disk I/O. Like in every measure except the CPU, Docker and containers far outperformed KVM-based virtual machines. So there's that. So machines are like using only half your resource. Spoken in terms of CPU, like you don't get much overhead, much CPU overhead because of the hypervisor. Since you have like hyper-threading and hyper like VT and all that, VTX virtualization in the CPU. Since you have hardware support for virtualization, you don't get any CPU overhead, but you lose a lot of stuff when you talk in terms of network and disk I/O. So there is a study. That's what you asked.
You can share the link.
I'll share the link. I'll post the link in the page.
In this model, when you have 2 applications in one instance, for any upgrade or change in one application will have an impact on other one, right? They are bound to give downtime.
No, so ECS. So we also do this blue-green deployment. So we provision an additional set of servers and then deploy the new code in that one that we did. And the second experiment that we did was in ECS itself. So we just update the new container image and it automatically does a rolling deployment across all the containers. So the magic of ECS happens because in each of these base host EC2 container, EC2 virtual machines, we have something called as an ECS agent running. So that ECS agent actually manages like the deployment, etc. So all I have to do is deploy the new version, change the update the image, and it gets deployed in a rolling fashion. So that's also done by ECS.
We could have done that manually, but then here the ECS agent is taking care of all those things, the overhead that we were having previously. So that was a pretty good advantage for us. Why to just see? For us, there was a different. Rather than just focusing on the infra, now we are focusing on the code. Difference.
It depends on how you want to like
version.
like the new cluster and run that different version in different clusters. No, we don't have that. So this is just a summary of like what happened. This was, as I told you, a big revelation for me because I never thought adopting Docker could change the way I am actually designing my application. And this is the question you asked. Do we definitely need Docker for hosting two applications in one EC2 instance? No, we do have like options, but the options are like clumsy. Yeah, the hosting choice for us was ECS because we are a AWS shop, and that was the first thing that we evaluated. For build, we are using code build, again an AWS service. It is so. I think some of you might be familiar with Travis CI. It is something very similar to that. They have modeled it. We had to have one build spec or something .yaml in our root directory, and it will build it. And the beauty about code builders, you already have the security groups, the IAM roles, etc., created in AWS, and it's beautifully integrated with the whole ecosystem of AWS. Code build to build and upload the Docker image into the ECR. ECR is the registry, Docker registry provided by AWS. So one of the long-term goals for us is going to a continuous delivery mode, and we are also looking at things like code deploy and code pipeline. Both of them don't support ECS, but I believe that that seems to be a very obvious limitation in AWS, and I am sure that AWS will be like building this and launching it very shortly. So we'll just wait for these things to happen, and we will have a CD pipeline also. Currently, from the CD perspective, the deploy part is done manually in our staging, and we plan to do it manually for some time in production as well.
What about the continuous integration?
So the continuous integration, so what is continuous integration? We need like repeated builds in a clean environment, and we need to like run the test. So all those things can be done in code build. When we talk about continuous delivery, that means the deployment also becomes part of that pipeline. So that deployment is what is missing currently in these two tool sets. So this is basically like for people who are actually new to ECS. I'll just quickly run through the workflow of how to like deploy in ECS. So the developer codes in Git, and the code build service, it actually builds the Docker image and pushes the Docker image into ECR. ECR is EC2 container registry. It's also part of the ECS console, AWS console. And we have something called as versioned task definitions. and task definitions can be versioned. So like many of you are new to Docker, but something called as Docker image, and we have the runtime version of the Docker image, which is called as the container. So when starting a container, we need to provide certain runtime information, which host port to map to the container port, which environment variable to pass on to the Docker. And there could be a number of details like this. What is the hard limit for the RAM that can you allocate for the Docker container? So these details are defined in task definitions, and combining the image and the runtime definition, you create something called as a service. And in the service, you will be defining how many instances of Docker containers do you need to keep running. So traditionally, like we have been used to things like supervisor D, Monit, or even PM2 for some purpose. The service running, even if the process goes down, we automatically bring it up. The service configuration in ECS will ensure that you don't need any of these tools to keep them running. It will ensure that the number of instances that you configure, like I need 2 instances of my microservice 1 to always be running, will ensure even if that goes down, it will automatically bring it up. So that is the service configuration. The last is the cluster configuration, where you will be defining the machines, the easy to host machines, and what memory, what RAM, etc. The details will be defined. So this is the whole ECS life cycle.
Do we want to create the Docker images for every?
Yeah, that is so when we started talking about Docker with the developers within Flashdesk, one of the pain points they felt was about this addition Docker. Because Docker image, when you're building it, it is always building in a clean environment, and what are dependency resolution it needs to do. NPM or Maven, it always does it from the beginning, and it was an overhead for them. So that is when we actually moved to code build and help them. So the code build in the background, it always, like every morning, I together code build.
Okay, but when you create the Docker images, you will say what are the softwares there, and what the version of it. Install the create a Docker image from there. So it could be created once itself. When we need change, we can create again a Docker image.
No, we create the Docker image along with the code. So the question is, he's telling like, can we? So Docker image is basically the environment where the code is running. So can't we just create that environment and save it somewhere? And then
we are using Docker images. What we do is we have a separate environment for code session. When you're running the Docker commands, so just we mount the path where the code is built. So images will be created at once. If any we have changes, we will create again. Otherwise, the mount code will be mounted. So every time the code part will be updated. So using like
so we are talking about 2 different use cases. One is this deployment use cases in staging and production, where we actually package the code. So Akhilesh will be giving a demo on the volume mount and doing that activity. We don't want each and every developer to like set up the environment and use that.
In terms of that, so when do we need to create a base image? So if we have got a set of common environment variables, and if those change, then we have to make a new image now. So if the number of environment variables that I'm passing through the CLI are like too much clumsy, then I'll Docker file. Otherwise, if there's just one param to be changed, then I can directly do it through the CLI now. So that's what he was trying. So for every build, if we are having a different release itself, then we will make a new image. Otherwise, yeah, we'll directly use the CLI.
What's the size of the
size was pretty small. I don't remember that. So we typically use Alpine images, which is like very minimal Linux images. So tagging, how we do it is we have developed a custom shell script, and when we are doing a code build, we specify what git tag to use, and the same git tag is used for Docker, like tagging the Docker image as well. That is how we are managing.
It will automatically pull and then append it to the Docker.
Hey, this is just like one screenshot of the ECS console in AWS. When I first saw this, it was really confusing. Like, what is the repository, what is task, and what is cluster? So, just wanted to show that it's not very complicated, considering that you know this workflow. If you understand this workflow, it's pretty easy to understand the console and get started with the ECS. Okay, and I've set up my personal laptop with personal AWS account. Anybody who wants to can free to join after this talk. Okay, so I covered the design and DevOps part, how it is impacting us and such this. So handing over to Akhilesh for the code and QA part.
Thanks a lot. Code and QA, so one of the most crucial parts of the whole software lifecycle. So how did we get so in terms of code, so the major issue so we were a startup, now we are an enterprise level startup. Things changed, people increased, and the one major issue that we were facing was the onboarding. In terms of when a new employee comes, it takes around 2 to 3 days to just like set up his environment on his host machine. So that was causing a loss of productivity. So how could we solve it? So we Dockerized it. So the 2 days that it used to take, 2 to 3 days, because a lot of dependencies were there. Because it was a monolithic application that we still use. And yeah, so we just Dockerize it with a Docker file. And if I have a Docker file, I add the dependencies without even setting it in my host machine. I can just directly run the Docker, and yeah, the environment is already set up. So within like 5 minutes, I can check what my code changes were. After, I'll even show you a demo on that. So yeah, first problem we solved it because yeah, it was too complex. And then the second issue was microservices. As you said, we started with Rails and then eventually went into Go, Java, and a couple of other stacks. So if I'm working in the platform, so I'll be working on multiple stacks. But should I know, should I even get to know how to run a Go application or a Node application? I don't want it, because that is again an overhead for me. I have to again depend on the other teams. Okay, I have to go to them, check out, okay, what's the issue? And the runtime issues are like too much. So yeah, rather than even knowing that, I could just pull it. I can just use it as a black box. So without, I can run my integration testing. Yeah, and yeah, 2 days, and even like depending on other teams, that just got resolved to like 2-3 minutes. This was one, and yeah,
a couple of questions on the previous slides.
Yeah.
So the solution that you said, like you went to Docker, right? Like since you wanted the dev setup to be running as soon as possible. So why didn't you go for an image like where you already have a standard image and just create a that has an image so that you don't have to do the installation?
See, again, up in the VM, I have to again pull it. So VM will itself cost around like more than 1 GB. A typical VM, if you talk, because a lot of dependencies are there. And
no, yeah, just forget about VM. Like even in your local desk, right? Like your laptops or your desktop, like you can have an image and you can just spin up a new system in that.
See, sharing an image and sharing just like a 10 KB file.
How about Vagrant?
Vagrant?
Yeah, Vagrant.
That would be only for just a config.
Multiple strategies for dev staging or whatever.
But it's talking about development environment.
Yeah. So
yeah,
we don't want to have multiple strategies. So be it dev or be it a isolated setup for staging or even
what you're talking about is the environment, but what you're talking about is
the dev environment itself. We have got multiple strategies.
Or the developer's environment.
To developer's environment, when we have, so every developer is working on a different environment.
Right.
Though the app is same. So there are multiple strategies how we run it. So on a staging, we run it differently. On a pre-staging branch, we run it into a different stack.
So what do you mean is the developer will go to the each and every environment to develop it?
No, he will test on that. How?
If the developer will test on his staging environment.
So that depends. He will test, okay, how it is working. Because everyone will have a different set of dependencies. So in a pre-staging, we are using some other thing. And for that, on staging, we are using some different version of it.
So this is about the monolithic applications that we had. Okay, what happened was these were kind of becoming a monster. So when I kind of start this Rails application, I would have like 10 dependency failures because native compilation, all these things, SSL library issues, etc. So what we did was we created a kind of a Docker file and committed along with the code. So anybody can just do a Docker build dot and it will create the image and he has a complete running environment. All he has to do is mount the source code and he is productive. So in his personal laptop, he wouldn't have installed Rails or anything. So this is the advantage that we had. And like working on the platform team, we will be like working with multiple APIs provided by different team. You can go, one will be in Node.js, but we don't want, just as a consumer, I don't want to like install, set up all this, the correct version of Go for one stack, the next version of Go for the next stack. Bring up Docker images and start like linking it, consume it, and start developing my code.
Tell you one more use case. So yeah, in terms of microservices, being a platform guy, so we were using 2 versions of MySQL. I cannot use that on my host machine. So how do I do that? I need like 2 versions of MySQL running for 2 different apps to talk to each other. For that, we again went for containers because container itself is an isolated environment. I can run multiple microservices in a container. So that helped us a lot. Yeah, so even from the QA perspective, the issue was, so initially we were small. And okay, so then it was much easier for them to come to the devs to get the setup done because for them, before pushing it. And that was again a pain for them, depending on the developers and getting the time. So the shipping was taking a lot of time. The releases were delayed because of we were going through a pretty good learning curve, how it is. So then, yeah, for a QA, it should be a black box, what we thought. But then they have to again like set up everything on the host, test it. But yeah, we Dockerized it. Now for them, we just provide them the IPs, and that is again hosted on the ECS. In terms of it even saved us cost because 30 to 40% of the cost was going into the staging machines. That was just for testing. So that we got it reduced to like 2-3 EC2 instances. We can use it and have multiple containers run on it. For that, we can have simultaneous builds that they can check what was the issue with the previous or the other one, anything. So yeah, that yep. Yeah, so being me a developer, and then yeah, my code on my host machine. So I'll be mounting that to the runtime. So I'll probably start with the demo, a small demo. So I'll be mounting the code to the container, and I'll be showing without even restarting my server or doing anything. I can see the changes in the code. So yeah, pretty easy to do. So I'll show you a pretty clean Docker file. Not much dependencies here. So how many guys are like familiar with Docker file? I suppose everyone is. So probably you would be knowing the syntax, how it is. So from 2.3, that's a base image that's available on, that's an open source image available on hub.docker.com. So I could have used Jesse Ubuntu image, but then I'm using Ruby 2.3 because it has got the Jesse plus a Ruby installed. I don't need any overhead of Apache, MySQL, anything. So pretty clean image and a pretty small image. So this helped me. And then the run is I'm installing the dependencies just to run, and the working directory that will be in my container, and I'm copying the gem file. So gem file is again based on Rails, one of the where you have all the plugins and libraries to install. Copying it and then yeah, exposing. So the service will be listening on port 3000 in the container network. So and the command which will be running So this is a Docker-based directives. Yeah, I'll show you. I'll run that. So I've already. Yep. So I just got the image ID. So what I want is I want to run that container on on the port 4000 on my host machine while it is running on 3000 in the Docker machine. Even mount the code. Sorry for that. Even show you so how the architecture is. So about volume mount. So this is my host app, my host. So I'm having a different path up here and a container path. So container is since isolated from the host, so I can always change my code path and deploy it in the containers. So with the same host path, I can have multiple containers running with different environments. And then the port mapping. So I can have any random. Typically, if you don't mention a port, so it will locate a port in the container onto which it will be listening. And this would be the host port onto which I want to listen for my service. This is the architecture. We did a Docker build which is, I would say, I ran the Docker file, which is a template of instructions that made the image file. Then we did a Docker run. So Docker run, what it will do is it will run the image, an instance of an image. An instance and a runnable instance of an image is called a container. So this is a Docker host, the Docker daemon. So I've got a base image, which I just showed you, which I created from the Docker file. Then I'm using that an instance of that to run as a container. So I can have multiple containers run through the same base image as per the environment I want, the variables if I want to change as per the config. And then yeah, and as I said, so we did not go through the Docker pull because when I did a Docker run, that image was already there in my local repository, the Docker hub. Otherwise, if I just do a Docker run, it will actually pull the same image tag from the Docker registry that is open, or if I want to mention, I can have a private repo also. Yes, yeah. We did a Docker run and it started the container. A small app I'll show you. Yeah, so the server is running. So this is my host port, and this is the one that I'm running in the container. So a small app. If I go to a new article, say like, hey, I'm Akhilesh. So I'll change this without even changing any of the environment or restarting the. Yeah, and Dockerized. See, so since the code on that, so without even changing anything or building it, I was able to see the changes, and I don't have any real setup in my host machine, so that helped me a lot. So analogously, I can have multiple services running like this, and it made the overhead just go down to 0. So yep, pretty much this. Thank you. Any questions? We'll be happy to help. So
Please have a question.
Yeah.
Right, authorizing any ID IDs for developer?
not yet. So we don't need an ID for that, I suppose, because like the Docker directives are like pretty small. So only few of them have to, but the usage should be.
When you said without doing any build, right, does it
Yeah.
still apply for the compile time language?
No, for compile you have to again do
build, right?
not a build, Docker run of the container, a new instance of the container. Why to again build the same image? Because the image does not have any of those. So, because see, this thing will be done on the runtime when you need the build. Yes, because this is all. Yep.
The staging environment, do we mount the code on the host machine or do we have the code inside the container?
It is in the container also. So from the host, it is in the container also. Otherwise, how will it like map? Wrote in the Docker file.
Volume.
Yep. I'm sharing the volume.
If that is the case, we cannot share that images to someone else, right?
Share the images in Docker.
Let me answer that question. So you are asking about the staging environment, right? In staging and production, we are actually packing along with the code and pushing it.
Yes. Okay.
So it is one image which gets promoted to different environments, staging, production. So that is the CD pipeline that we are planning. So it is packed with code.
So in that case, we'll not mount any code on the host machine.
Not be mounting. We do mount path. For example, the logs we want to mount it because we don't want it to like fill up the system.
Docker images will be registered in some registry. We have some Docker registry.
Yeah, ECR.
ECR.
Not only there, we have a Docker registry also separate.
External Docker
So when we push it to that, we have a code inside. We asking that only. But also, we have a code in that image. If someone pushes the image, they can see our code.
It is public and private, so you have the access control. How you want to control it. So ECR is completely driven by IAM rules. So it's completely
So
secure.
even if you push on the private registry of Docker, you have the access. If needed, otherwise don't need. Yeah.
How many Dockers do you run in a container? One software per container?
We can have n number of microservices running. It can be like, depending upon the number of PIDs a machine can allocate, we can run those many containers, and in that, yeah, again the hard limit of the container, how much are we able to use?
So my own pattern is basically we use Docker Compose for this, and like if an application has Redis, Memcache, MySQL, all these will be separate containers that will be linked via Docker Compose. So Docker Compose has this useful host name pattern, and we just have to give the host name of Redis, and it will automatically connect between the containers. So parallelly, you will be running 36 containers. When you do a Docker Compose up, be coming up, and each of these containers will be accessible by a host name. So Docker Compose is part of a normal Docker installation. I would encourage everyone to like explore that for new people. It's just an awesome tool. So we use that.
We have to run 5 different containers for 5 different applications. If I'm running like in a single load for a staging environment, how can I allocate different resources for a particular service?
No, when it comes to staging environment, it's a totally different case. So in staging environment, we don't use containers for hosting a database. For example, we are using RDS, we have AWS. For Elasticache, we'll be using for Redis and cache. So it will be like pathway environment variables, how we use that staging environment. So staging is a good document. For developers, sometimes we give this ability to run the whole stack using Docker Compose.
But in any case, can we allocate, can we have a reserved kind of system allocated to a particular domain?
So local, I don't know. There will be definitely options in the Docker command, but I don't know. Staging, for example, in ECS, we have the option of telling like what is the hard limit on the memory. So for our current application, we are given like 12 GB. If it consumes more than 12 GB, it will be like 6 or something. Okay, so this is how
The hard limit is based on the system resource of the host machine.
it is on multiple things, how my application is going to behave, and based on the host machine size, we balance it.
So here we found a single volume. So
if you have multiple containers, you need to share a common
Then that has to be done through the cluster because
just Docker.
So we are exactly doing this. We have two containers and we have the log folder. So we want the same path to different containers. So that is being done. Both these containers will be writing to different log files in that. And the host machine, it will be streaming the CloudWatch logs, etc. And log.8 and all this managed at the host layer. This is how we are managed.
We have different
mounts, different volume mounts on different containers. How do we do that? Right now we are mounting.
Let's say we have a strong cluster and different documents are there, and we deploy container to different machines. But we need to share a common.
Talking about
one option is there, we can share a container, storage container across all other containers. In enterprise level, how we can do?
Like NFS or something, sharing the volume across different network cluster nodes, right? So if they don't use NFS, that's about like the logs is one use case, but logs we stream it to CloudWatch logs. So we don't have that network share model in the applications that I have seen. Somewhere else in such that they might be.
If you want containers across multiple EBS, mount one EBS volume on all those. Mount a volume on that EBS instance, then share it across. So all containers can communicate to the EBS volume, but can probably have different directories. Whatever your structure you need, you can have it in the EBS volume. AWS back, so our thought process will be aligned more towards AWS. But whatever cloud service you cloud or even on-premise, you can manage it.
Do you manage database inside the container?
No, we use RDS.
RDS.
Even for dev?
No. Then we use Docker Compose and bring up the whole
Including the database?
Yeah.
Then it will be in the.
You can bind as a service in your database, in your YAML.
Whenever there are multiple services there, so how do you usually connect? How does service discovery?
So service discovery, like in microservices, how we are planning is we have our own staging domain and we are using a DNS solution only. So we know about Netflix, like open sourcing some components for service discovery. Like we are not using any of those components. It's plain DNS with subdomains. So we'll wind up. Thank you, guys.
Hey guys, you got some break. You have snacks over there. You have drinking water outside. We'll get back in about 10 minutes.
Okay.
We can't use that card.
Balaji.
On my front end.
எப்படி இருக்கீங்க?
நல்லா இருக்கேன். நீங்க என்ன டாபிக்?
இல்ல நாங்க இது
Windows set ஆகாதுன்னு
My name is Mohan. I'm a student and an organizer for the Docker Meetup. So today I'm going to present about container orchestration, and before that, since we have a lot of beginners, I'm going to get everybody on the same page for what a container is.
Wait.
So basically, there is not much to do about you can use Docker entirely using these last two commands. That's all. You have only run. That's all you do with Docker. It boils down to what you understand about Docker conceptually. So Docker as a tool is really simple. You can just use the man page to understand what it does. Even you don't actually need to read the man page. You can all these commands are self-descriptive. What pull does is it pulls the image from the repository, the Docker hub. And what run does is it automatically, if you don't already have the Alpine image, it pulls the image, and then it creates a container and it starts the container. And naturally, you also have a separate command to just create the container and just start the container. And you have commands to delete containers, delete images, and stop containers and all that. All those commands do just what you think it does. So there is nothing much to talk about Docker as a tool. So mostly it's about Docker as the concept. That's what you need to understand. So the first thing is Docker underneath it uses something called Linux containers. But there is no such thing called a Linux container in the kernel. What you have is C groups and namespaces. What C groups does is it limits what a process can use. It kind of specifies that the process can use only some megabytes of memory and some percentage of the CPU. That's what it does. And namespaces, what it does is it puts the process in a namespace. What it means is the process can only see other processes in the namespace. You cannot see processes outside the namespace, but the processes that are outside can see the processes inside the namespace. So you get this nested process-like structure, right? If you do a PSA, what do you get? How many of you use Linux, Linux or Mac or any Unix distributions? So what happens when you do PSA? You get a list of all the processes running in the system, right? When you have this nested processes, there's this another tool called PS-tree. PS-tree does PS-tree says which process started which process, right? To find the namespaces. I forgot its name. So what it does is it tells you which process is nested inside which namespace. So the thing is, only the processes inside a particular namespace, process isolation using namespace. Even without control groups, you can have containers. Since the process inside cannot interact, it doesn't know the process outside. It doesn't have the PID. So how will it contact the other process? So it cannot, right? You achieve process isolation. The very reason why we use virtual machines is to achieve process isolation in most cases. If you disregard security, mostly you use virtual machines to achieve process isolation, right? So namespaces gives you that. So why would you need virtual machine? That's the whole goal of using Docker, whole point of using Docker. So the thing is, there is this thing called Vagrant. How many of you have heard about that? So you might think that Docker is Vagrant LXC, because when Docker first came out, we all thought LXC, right? It's the same thing, right? When you use Docker, what you do, when you use Vagrant, what you do, you download. We used to deploy to Heroku, right? So you pull the Heroku image from Vagrant, the same thing, the image that has the same config and properties as Heroku, and then you develop inside that. In that way, when you deploy to Heroku, you don't face any configuration issues, or you don't face any other normal issues that you get your own laptop. You're essentially shipping your own machine. You are shipping your machine to the prod, right? That's what you do. That's what you used to do with Vagrant, right? That's what like, but we didn't use Vagrant like that. Most of us, we use Vagrant only to set up the dev environment, our machine. But Docker tells you to do that. That's the difference between application containers and machine containers. When you use LXC, what you're essentially creating is a machine container, right? What a machine container does is the same thing as what a virtual machine does. It gives you a whole machine. It gives you the whole stack, right? But what an application container gives you is the bare minimum that an application needs to run. That's what an application container gives you. You can deploy the application container, and since the application container has everything that you need to run it, it'll run the same way no matter where you deploy it. It'll run the same way in your development environment. It'll run the same way in the staging, and it'll run the same way in the production environment. So that's the thing. So the thing about shipping your machine is, right, you might have like people who have worked in ops would know this. Work in the developer's machine, our machine, like the production service, right? And when you go tell the dev guy, what would he say? Like he would say, it works in my machine, so it's your problem. That's what he would say, right? So the way Docker fixes this is by letting the developer ship his own machine to the prod. So, and Docker gives you this packaged environment, right? You can only communicate with other containers or other external services only using published ports. There is no other way you can communicate. Like you can mount file systems and do some IPC stuff that you normally do with processes, but that's not the way people do things, right? The only way to communicate with external services is through ports. So it gives you a kind of abstraction that you can reliably schedule and like deploy from one place to another. That's basically Docker.
Please highlight on C groups.
Sorry?
Highlight more on C groups.
C groups gives you like, it lets you specify. Somebody asked over there, like, how would you specify how much a microservice would use? Right? That's what C groups does. It lets you specify how much CPU and how much memory process a container can use. Like you construct containers using C groups and namespaces, right? So what containers are essentially processes. Normal processes in your Linux system. That's what containers are. So, but what's the difference between a Linux process and a container? I mean, a normal process and a containerized process is that the process inside a container cannot see the process outside the container. They're all using the same kernel and they are using the same system call and they get scheduled the same way. Like if you have, the OS scheduler, right? There's ways to schedule stuff between different threads and different processes. It uses the same thing. Like it will schedule the container as if it's a process. The only thing is the process inside the container cannot see the process outside the container. That's what namespace does. And what C groups does is container, it limits the amount of resources like CPU and memory, what the process inside the container can use. C group stands for control groups. So you can control what the process does. Like if you have a rogue process and you think it is starting to leak memory, you can limit it to 128 megabytes and it cannot cross 128 megabytes. The kernel wouldn't allocate it any more memory. So if the memory doesn't get allocated, the process will naturally die, right? So if you want to know what Docker containers are running in your machine, what you do is Docker PSA. Then it'll show you all the containers that you've ever created, even the ones. Okay, so all the stop containers, everything you can see using this command. So this is like the normal PS command, but it shows you the containers that were created using Docker. So that's pretty much it about Docker, like conceptually. So if you have any questions, you can.
Actually, just in a container, just if I want to run two different applications, if I run the two different applications, I want to add more resources for that in a specific application. So not for the container, the specific application. How we can achieve that?
What you're asking is like you have more than one service inside a single container and you want to allocate resources to a particular process, particular service inside a container.
Just take
You
an
don't do
example.
that. You create one container per service. Popular phrase called one process per container, but that's a bit of a loaded phrase because you can't actually live with one process. But the thing is, if you have one service, if a set of processes, mostly one, do something, do one thing, you put that inside a container along with all the configuration files and everything else that it depends on, and then you ship it. So you don't allocate resources to a service inside the container. Resources to the container.
I have one though. In normally, if you install any application in Valve or Debian, we normally use
RPM.
or
Yep.
So it's like in each dependency is installing in the main machine, right? So when we are using this Docker, so will it replace all those things?
No, like that's the thing. So RPM and Deb, right? There is this new format from Canonical called Snap. The Snap works the same way as a Docker container, except Docker gives you like a way to ship that application to the enterprise. Snap gives you a way to install applications in your own machine. So what Snap does is, how does a normal package manager work? It creates a dependency tree and it downloads all the dependencies that it has, right? What containers Docker or Snap does is, when the developer packages the application, he packages everything the application needs inside the Snap or inside the container, and he ships that container. So like, let's say your application works only inside Ubuntu, right? But you want to run it on, let's say, Arch Linux. What does Arch Linux not have? Tell me some file that Arch Linux does not have, but Ubuntu does. Okay, let's take XYZ. There's a file. There is some file in etc that Ubuntu has and Arch Linux doesn't. So your application runs only inside Ubuntu. What you do is when you ship it as a Snap or when you ship it as a container, what it does is, just for that application, you have this file system. You have the Ubuntu file system. There is this. So from the perspective of that application, it's running on a Ubuntu machine, but your actual machine is an Arch Linux. There's this tool that has been around since I don't know, 80s. It's called chroot. So Docker is chroot on steroids. That's the marketing phrase that they're using.
Yes, actually I'm from Debian community. I'm packaging for Ruby and Rails. So still we are packaging individual dependency.
Still you're packaging it?
Individual dependency.
Okay.
Application. So will it replace those things?
Yes, the Snap. If you're packaging your application in Snap, it can run pretty much on anything that has the Linux kernel. So yes, it will get replaced, Debian. But the thing is, you have this. The Debian has only the stuff that it needs, the dependencies, right? But you are essentially, when you're using a Snap or a Linux container or a Docker or anything, you are essentially like shipping the entire file system of an operating system, right? Like if your application runs, like I said, if your application runs on Ubuntu and you're shipping it on an Arch Linux, you ship the entire Ubuntu file system, the whole thing, the whole root directory inside the container, so that when you run it, it does a chroot inside the file system that's been shipped, and it starts running. So that's the way it gives you an illusion that it's running on Ubuntu.
Yes. In future application, we can when we bring into Debian or Run, still we need to package the dependency, right? Normally in Debian or Run, we are using applications or Docker engine. Still, we need to individually package all the dependencies. Then only the main application will install.
Like to run inside Docker, you mean?
No, the Docker itself need to bring into Debian, right?
Yeah, it's like,
so each individual dependency we are packaging, and we are
Docker would do to app what app did to tar, right? Nobody uses tar anymore. But if you want to install the app itself, how do you do that? You just curl and tar, right? Curl tar and make stuff. So that's the thing. So you will no longer use app to install applications, but the application developer himself, if he needs any dependencies for the application that he's packaging, he would have to use apt or yum or whatever. Anybody, any other question?
When you say process inside this container cannot see the communicate the process outside the container, so that is there any specific way to monitor the process inside the container?
No, like how do you talk to me? Like you need like to do any kind of inter-process communication, you will need the PID, right? Since you can't see the PID, you don't get the PID. Even if you inside the namespace, if you give, let's say, I want to talk to PID 1, it will give you, I mean, it will tell you I don't know any PID 1 because the PID 1 is outside the namespace.
Is there any workaround solution to?
Sorry?
Is there any workaround solution to achieve the monitoring?
What do you mean by monitoring actually?
Actually, container one is yeah, we have spikes on container one.
What do we have?
Just example, we have for hosting is multiple containers. So some spikes on container one. We used, as per you said, we are able to find using the namespace which is using more IO or something. So in the container, how do we can troubleshoot which is using more? Yes.
They have developed their own algorithm for what the system goes. Use this namespace and C group.
So like if it exceeds the C group, Docker engine will kill the container actually. So there is a spike. If the container is behaving in a rogue way, it will just kill the container. And if you're using some cluster orchestration tools, the orchestrator will actually restart the container. So that would be
Something related to memory. Actually, we have two microservices. Same two have the same resource. Something have Ubuntu and same dependencies. Containers. How the memory will be allocated, or will we use same resources?
When you like, if you're using Docker, when you do a Docker pull, it won't pull the layers that you already have, right? Let's say you already have Ubuntu tag latest in your machine, and then if you put something like Ruby 1.3, which derives from the Ubuntu latest container, it won't pull the Ubuntu latest container again. But when you create a container, however, what it does is it still copies the whole file system inside the container. So if you have two containers running two microservices, both have Ubuntu, you don't actually have a copy on red file. You still have the whole file system.
So memory will be the same. That install memory or
yes, but that kind of depends on which file system that you're using. What do you mean by memory? You actually talk about disk space, right?
Disk space.
So the disk space that really depends on which file system that you're using. There's this new file system that has support for support for even like sharing layers between containers. Since it's only read only, right? You cannot actually modify. When the modification happens, it creates a new layer and it like modifies on top of it. So that's how it works. So if you're using that file system, you can save space between two containers that are running same image. So in that case, your container would have only the layer. I mean, only the disk space for the stuff that you have inside your container, not the Ubuntu image. So anybody else? Can we go to the next slide, please? So talking about immutable infrastructure, right? There is this new movement called immutable infrastructure. What it does is, once you've deployed a container, you don't like SSH into that container and modify things. You don't like use Ansible, Chef, Puppet, and all that DevOps stuff to manage a container. If you need to make any modifications to a container after you've deployed it, you just deploy a new container and bring down the old one. And also, somebody was asking about communication between containers. so a communication between containers on different swarms, right? You don't actually need to communicate between. I mean, you don't need to store stuff on a common volume, right? If you need to do that, you'll need to use an external storage service. Since 2005, we've been doing all this cloud stuff. Application servers are stateless. They don't store any state at all inside their machine, inside the VM. Since that has been the way since 2005. You do your compute inside EC2 and you store your stuff in S3 or EBS. That's how things have been, right? So containers are also naturally stateless. You don't store any state inside the container, and you only if you need to write something to a persistent storage, you use EBS in a cluster, and if you have some complicated engineering skills, you use something like Ceph, and then worry about your performance and stuff. So what is orchestration? So we have this new thing called orchestration that you hear everywhere. What do people think it means? When you hear the word orchestration, do you see a person with a stick in his hand guiding conducting the machines? So what orchestration actually is it can create clusters, can manage resources in a cluster, schedule processes inside a cluster, right? That's what orchestration means. And by processes, I don't mean the actual Linux processes. It can be any task or something. Then these are things that you actually need, but the orchestrator doesn't really have to be doing these two stuff, monitoring and managing the tasks. I mean, giving the user a way to manage the task. That's what I mean by managing the task. So that's what an orchestrator does. And you have this 2 dozen orchestrators that has come out in the past 6 months or something. But we only most of the time, most people use only orchestrators. One is Swarm, which comes with Docker naturally, so everybody has it. And the other thing is other thing that predates Sauce, which is based on Google's Bog. And the other thing is, which is everybody's favorite, Kubernetes. So we'll talk shortly about all the three orchestrators. So Docker Swarm is incredibly easy to set up. What you do is you Docker Swarm comes with the Docker engine. When you install Docker, you have Docker engine with it. So all you need to do is you need to say Docker Swarm in it and then post an IP address, right? And then from the other machine, from your node, you do this. Let's say the node also has Docker installed. I mean the slave node. Yes. It just joins the swarm. And after that, if you start using Docker like you normally would, what it does is it schedules the containers between these two machines. So that's just very easy to set up. Provided that this address, I mean, if you want this machine to join this address to this machine should mean this machine. You know do you understand what I'm saying? Right? If you're on different networks, okay, so this is my local network. This is a machine also on my local network. So I mean inside my LAN. So 192.168.2.5 from this machine means this machine. So this would connect. But on the other hand, if you try to connect 192.168.2.5 from your machine, that would mean some other machine in your local network. So you cannot actually connect. So do you understand that? This address, right? What happens if I put this address on my machine? My machine, this address denotes a VM. So I have a network connection between my host machine and the VM, so I can communicate with that machine. So I've advertised this address on my master node, which is my host. Then I go to my VM, and then I type this address, right? I have this token, and then I try to join to this address. So I can do that because there is a network connection. But if you try to do that from your machine, you cannot do it because you don't have a network connection between my node and your machine. So that's the thing, right?
So you need to say that 2.5 can be any other machine.
No, what I mean to say is 2.5 from my from the Swarm node is my machine. From my Swarm node is the same from your machine. I have a public IP, right? If I do, I have a public IP that starts with 172 or I don't know what that public IP is. When my machine connects to the internet, if I had used that IP to advertise, you can connect your Swarm, your node to my Swarm. But I haven't done that. I use my local IP address, my LAN IP address, right? So only the machines inside my LAN can connect to my Swarm.
Any other machine the same network can connect.
Yes, right? Yes. So do you understand that part? So every machine has multiple IP addresses, right? You have a local loop pad, which is 127.0.0.1, and then you have your local IP, and then you have your external IP. Then for every network interface that you have, you get your own IP address. It depends on which IP address that you pass to advertise address. Network Swarm. So
it's like another network.
Your actual network, right? Your actual network. And, what matters is which network you're running the Swarm on.
By quantity square, what does it mean? I don't have clarity. So, confirm AWS. So, actually, so when an instance is booted, you have one public and one private IP, right? So, if I say advertise address and I give the public IP, then from my home can I connect to it?
Yes.
So, how do I
the
know?
external IP is accessible from any machine, right?
So, then there might be thousands of ways all over the world publishing their public IP saying.
You need the token, right? You don't give them the token.
No, but what if I don't want to even say that?
In that case, you create a private network. And I mean, between
But
all the
still, I
nodes.
will have to publish my IP. So instead, I publish my private IP.
Yes. Here in the advertise.
Even VPC you can give.
So, like I said, Docker, there is this tool called Docker Machine, which you might have heard. What Docker Machine does is it has what do you call that, drivers for various cloud providers and even your local machine, VirtualBox and VMware and all that. It creates a VM with Docker pre-installed in it, right? That's what Docker Machine does. So if you want to create a swarm, what you do is go to the Docker Machine command, specify the number, and give it your cloud credentials, and then it starts. It just creates all the nodes for you. So it's internally like a cluster in 3 seconds plus whatever it takes for the cloud provider to bring those nodes up. That's all you need to do. So Docker Machine is that easy to set up. After doing this, you can do Docker Swarm in it on one machine, which becomes your manager, and you can start, like either manually doing it, or like you can SSH you can SSH post commands to all the machines, and all those machines will be in your Swarm in no time. Like the entire setup process will take less than 10 minutes, let's say. So, but that's not the case with other container orchestrator engines. Docker Swarm comes with an internal Raft implementation. Raft is a consensus protocol that you might have heard about, pretty famous these days. So, so you don't need anything like etcd or Zookeeper or anything. Docker Swarm is pretty self-contained inside the Docker binary itself. So you don't need anything else from outside. But the problem is there is this thing called imperative versus declarative. How many of you have heard about this? Like DevOps people, Ansible. Like the difference between how many of you use Ansible? Okay, very few. Like let's say Chef Puppet, anything. Like, what's the difference between like SSHing into every machine and typing, okay, that's hard work. What's the difference between what do you asking? So exargs and exargs SSH and using something like Puppet, Chef, or Ansible. Sorry. What's the difference between doing your ops manually using exargs and SSH, some configuration management tool with like Ansible, Chef, or Puppet?
In a new instance, you have to do it again.
Sorry?
You begin a new instance, first you have to do it again.
That's
Within
the
a
way
file,
we
you can do
it.
everything manually.
With imperative?
You have 10 to 100
No, you
servers.
can like you let's say you have a shell script. You can SSH exargs the shell script to, I mean, you can SSH the shell script to all the machines and execute it. And you can pass all the IP address using all the IP address of your nodes using exargs. Why would you use Ansible or?
Oh, these are agents, right? Chef and all this agent will be running on the system.
Okay, that's the reason.
Let's say if I use a shell script, let's say we deploy an application and we need some configuration change. And if you rerun the shell script, that particular application, because we don't know whether it's actually changed or.
Yes, that's the thing. So,
as a code, we can set up.
So in the first case, what I said using SSH exargs and copying the shell script. Let's say if 3 of your machines have done something and 3 more machines have not done something. In that case, if you I mean, if you SSH again the entire node list, I mean, if you pass the entire node list to the SSH, what happens to the 3 machines that already is up? I mean, that has already changed. So that's the reason why you specify in Ansible and Chef and Puppet. You don't say what you want it to do. You say what you need. You say, I want the system to be in the state, right? And then you let Ansible figure out how to do it. It'll first check if the system is already in that state, or like it'll introspect to see which state it's actually in, and then it'll do the necessary modifications depending on the state to achieve the final state that you want it to. So that's the difference between imperative and declarative. The thing about Docker Swarm is that you can guess which one it is. I mean, did I tell you which one is which? Imperative is the way that imperative is SSH exargs thing, and declarative is Ansible way. Which way do you think Docker Swarm works? Can take guesses. Anybody want to take a guess?
Declarative.
No, it's imperative, right? You from the master node, you tell it what to do. It doesn't do any introspection stuff and all that. But the Docker people have a new construct called service, which is kind of declarative, but it's just a wrapper around it. But you can call it declarative. But that's pretty new, and I haven't had the chance to create a service yet. So, but service gives you all the nice stuff that Kubernetes does. You can do a rollout. You can Docker service. You can specify the number of replicas that you need across all the nodes, and the Docker service will have a control loop checking how many instances that you have right now, how many container instances that you have right now, and if one goes down, it'll try to create a new one to maintain your desired state. So Docker has that now, kind of, but the way most people use Docker is imperative. That's why imperative is like very simple, right?
So we have to tell what to do and how to do.
No. Yes. In Docker Swarm, you from the master node, you say Docker run Ubuntu, let's say some Apache Nginx. You create a server from the master node. You are telling the master node to create a server. You don't tell the master node that you need 3 instances of a server, right? That's the thing. So you need to do it manually.
Yeah.
But like I said, Docker has this nice wrapper called a service, nice high-level abstraction called a service that has most of these declarative constructs.
So slowly it's migrating to imperative to declarative.
What I don't understand is why they have this separate thing called Swarm if they're going to copy Kubernetes every time. Okay, then there is Mesos. Sorry?
Because it's like the development side of it, it's like JDK and the Spring framework, right? Whatever did in the Spring framework, after some time,
Or
it will be a
J2E.
standard. Yeah.
Seriously, I don't know anything about Java. I never, except for the college stuff, I've never used Java.
See, I have a doubt in Docker machine. Let's say DigitalOcean, we are spinning up machine. So this documentation actually create a self-signed certificate to communicate between different machines, right?
Sorry, what creates?
Docker machine. So we will use Docker machine with, let's say, DigitalOcean. So in DigitalOcean, we will spin up different servers, Docker engine. And in background, this Docker machine is creating self-signed certificate to communicate between different machines. In security point of view, do we need to create by
Yes,
SSL?
you need to get a separate security, certificate authority. I'm not really good with all this security authority and SSL stuff.
Let's encrypt.
Yes,
Let's encrypt it. But is it necessary? Because you have to communicate with
Only for Docker registries, self-signed certificate is necessary.
what I'm saying is that let's say we have a Docker machine and we install Docker machine and we have DigitalOcean. So we are spinning up different Docker engine machines to DigitalOcean. So there is no security point of view between these machines. If you are using self-sign, to replace with let's encrypt.
I'm not really sure. Like I said, even my project that I'm going to demo in a few seconds, I had to disable all the security SSL stuff. SSL is still there.
That we are using API.
So you're talking about from Docker master, Docker swarm communication.
No, from
Docker container to infrastructure.
Local machine we install with Docker machine. In our
Okay, like the DigitalOcean API would have an SSL, right? Would like encrypt all the
and we need the SSH, right? In Docker, in local machine, we are SSH to different machines. So in background, they are communicating. With
So I'm not really, like I said, I'm not really sure about this certificate authority thing.
While initiating the Swarm master node, there are different ways to discover services and service certificates as well. So he talked about initializing the Swarm master with the IP address.
No, we are not talking anything about Swarm.
Yeah, while creating a Docker machine, each machine will have its own certificates.
Yes.
The thing is, like while connecting to the master node, you need a way to have a common service certificate through which it connects with the master node. Is that your question?
No. It's actually Swarm is different. This Docker machine is different.
Okay.
Docker machine is like we can provision. We don't need to manually get into machine and install Docker from every time. Let's say 10 to 100 machine. But Docker machine, we can manually spin up easily. So this Docker machine actually will install Docker engine in each instance.
So first you should have a Docker engine in order to create a new virtual machine using Docker machine. We have different drivers. So we have some open source drivers like on the Hyper-V is there. Then we have DigitalOcean. Then VMware and many other stuff are there. So let's say like you are having a Windows laptop, Windows 10 Enterprise Edition, and you have a Docker engine installed in it, and now you are creating a Docker machine out of it. Like let's say like you are creating using VirtualBox. Then let's say like you are having 10 virtual machines. So each 10 virtual machines created using Docker machine will have a different service certificates for that. So now you tell me your question.
Yes. Let's say in the case of DigitalOcean.
Okay.
So it's using a DigitalOcean API to spin up machine, and in background it's installing everything. From local machine, we can access to different.
Yeah.
So we are communicating with Docker machine and Docker engine remotely. That means security point of view, it's creating one self-signed certificate. If you look into local machine and each individual Docker engine, self-signed certificate is there, and that is using for encryption to improve the security. So is it possible to replace that self-signed certificate with let's say encryption to improve the security?
The thing is like I didn't get the question very correctly.
So I have the similar setup in my office actually. I'm having 3 different nodes, not a single node with different virtual machines, 3 different nodes. Literally, these are 3 different Linux servers, which is in the UK offices. Okay, so I have installed Docker engine in this, and also have VirtualBox installed in it, and I have some 5 to 10 virtual machines created using VirtualBox in each of these Linux servers. So I have one master swarm, and each of these machines will have its own certificates. I'm not using that as that certificate actually. So I have a console. We have the swarm discovery tools like etcd or console. So I am spinning up the console container with some sort of common certificates. Okay, so with those common certificates, and also I have the particular the console service or container running will be the master swarm as well. So I will publish the IP address of the master swarm, and also the container will be, the console container will be running the master swarm as well. So while spinning up the console container, I will have certificates or security certificates, whatever. So while connecting the slave nodes, he talked about the token and the IP address, right? The common certificates, the security certificates to each of these slaves, through which they will establish a connection. So in that case, I think you can eliminate this security threats. Did I understand?
Yes, yes, understand.
They are all self-signed, right? So he's asking like, can they replace with any CA or other certificates?
Just because they are self-signed, that doesn't mean it's not.
It is secured. I mean,
It's just that you are the owner of the public and private key. So it's up to you to have the private key secure. So if it's authority approving it, it's just that guy saying your certificate is valid and what you have requested.
You can pass TLS demon level security.
So next we are going to talk about Mesos. I haven't personally used Mesos much. So, but why do we need it actually? Like, firstly, when Mesos was conceptualized, what was the reason they gave? Let's say in an enterprise environment, you need to run different workloads. Like you have a Hadoop cluster, you have a Redis cluster, and then you have let's say 2 load balancer, like 2 Nginx front-end cluster, and then you have some other service. Let's say you have different clusters. What happens when you have different clusters? I mean, has anybody managed a cluster? I mean, a cluster of virtual machines, right? Virtual machines or machines. When you are managing, when you want to manage different clusters, what are the things that you need to keep in mind? Every cluster needs extra machines, idle machines, so that it can grow, right? It can scale and all that. You need all these considerations. You need to keep all these considerations in mind. So what happens is you have in which only 10 works full time, and then you have 5 node Redis cluster in which only 1 works full time, and then you have 2 Nginx servers, one of which is backup on 1 works full time, and you have all this stuff where it's really inefficient, right? And then you have not just if you're in a big data environment, right? You have a lot of these big data tools and big data frameworks like Spark and all that. For different data sets and different job types, you'll be using different frameworks. A different cluster, a separate cluster for each of these things. Then you end up wasting a lot of idle service, right? So that's why Mesos was designed based on Google's internal thing called Borg. What it does is, instead of managing separate clusters, you maintain a single cluster. And if you have a Redis cluster, you have a Redis master and a Redis slave, or you have like distributed consensus and stuff, right? So instead of that, you create something called a scheduler, right? For every application type that you have, every different service that you have, you first create something called a framework. Every single, it's a Redis, like for every job type that you have and every service that you have a separate framework. Like for example, Reddit framework, Hadoop framework, Spark framework that runs on top of Mesos. A framework has a scheduler and an agent, right? The scheduler works on the master node of the Mesos cluster, and the agent is distributed across all these slave nodes. So every time the master, I mean, it has two-level scheduling, right? Okay, so it has two-level scheduling, contrary to how Kubernetes or Docker Swarm works. How Mesos differs is, instead of master assigning jobs to certain nodes, the nodes actually advertise that they have so much resource in them. Like each node will say, I have 2 CPUs, 2 gigabytes of memory, and 80% disk space, or 500 megabytes of disk space. It advertises what it has, the resources it has. It sends the resource advertisement to the master, and then the master sends it to its frameworks, all the schedulers that are running inside the master. First it sends to the Redis scheduler, and then next to the Hadoop scheduler and all that. And the scheduler decides whether or not to run this particular job on that node. So once a job gets scheduled, the node once again sends how much resource it has remaining, and the process continues. So it has two levels of scheduling. The scheduler decides, the application scheduler decides whether or not a job gets placed in the node. The main difference between how the other orchestrators and Mesos works. Since it kind of predates containers, it doesn't support containers by design, right? Because since it predates this whole Docker revolution by about 5 years, I guess. So it was designed for a totally different time. Does it make any sense for you to like modify your application code so that it can interact with Mesos API? You don't do that with Docker. Why would you want to do that with Mesos, right? So that's the reason why we have certain frameworks, already designed frameworks that lets you run either shell processes or containers. Marathon is one such framework that lets you, like what the word specifies, word describes. Marathon means long-running processes, and Chronos is Mesos's version of cron. Like it's the Linux thing that you use to schedule jobs that run periodically, right? So you use Marathon or Chronos to schedule stuff that you run on Mesos mostly. But if you have some legacy applications like Hadoop, you can directly run it on. It already has a scheduler. So that's how things work on the Mesos world. Yeah, and the other thing is, it schedules jobs, right? There's this huge problem called, there's this huge other difference that it doesn't schedule pods or containers like Kubernetes, or what it schedules instead is jobs, which is going to be a huge problem, because the next slide is, okay, when we talk about Kubernetes. So this is from the large-scale cluster management at Google with Borg. This is the paper's name. One of the major problems that they face with their setup in Borg is that jobs are really restrictive as a unit of scheduling, because you cannot actually change parts of the job, right? You're like scheduling an entire application. What an entire application can do, like when you're using Docker's Compose with Swarm, if you need to update like a part of your application, let's say your application has a website, a web server and a database. If the database has a new version, what do? You just update the database, right? You can't do that with this because so that's the reason why people don't do Vsauce type stuff. So Kubernetes instead has this concept called pod. What a pod is actually a collection of containers, but more often than not, you'll only run one container inside a pod. Kubernetes scheduler doesn't know this concept called a container. It doesn't consider containers at all. It only schedules pods across nodes. So this pod, this thing called pod, is the basic unit of app in Kubernetes. So, but pods can have, let's say, if the pod has more than one container, each container can actually talk to the other container as if it's on a local network, right? If you have two containers running on your local machine on different ports, how do you make one to talk with the other, right? How would you normally do? You would just specify localhost colon some port, right? You can do that if two containers are on the same pod. You can do that. Have some inter-container communications. Nodes are what you connect to the Kubernetes, right? All the slave nodes. You mostly have one master node. You can have multiple masters, but like you can have multiple masters that take over when one fails. But normally you have one master and multiple slave nodes. I mean multiple kubelets. We call them kubelets. So the master schedules pods to the nodes. So nodes are the physical machines, or it can be virtual machines, but it's the stuff that kubelet runs on. This thing called namespaces. This is like a very very helpful concept, because let's say you have a big cluster, like a 50 or 100 node cluster. That's a lot of resources, right? If you have a 50 physical machines, you can pretty much run the computation of this entire building. So what do you do with all that stuff? You cannot, like, if you give them all the stuff run on the same namespace, one can clash with the other and all that stuff, right? So essentially you create namespaces. What this namespace does is it makes a single cluster appear as if it's different clusters, many clusters. Inside each namespace, you see only the pods inside that namespace. You don't see the names. You don't see the pods outside the namespace. Like I said, with the Linux kernel namespace, I mean the process namespace and the user namespace. When we spoke about containers, it's the same thing. It's the same thing with Kubernetes namespaces. And then there's this thing called Kubernetes service, which essentially exposes your pods by creating a load balancer or something, like a node port or something. Exposes your outside world. That's what a service is. And using those primitives, they pretty much create a lot of objects, to be honest. Every 2 weeks we have a new object. So these are the ones that I know of, and these are the ones that I remember. So there used to be something called a replication controller. Even though the replication controller itself is declarative, we just discussed about imperative versus declarative, right? Even though the replication controller itself is declarative, the rolling update process was imperative. So that's a problem, right? Kubernetes wants to be very declarative, doesn't want any imperative stuff at all. So they created something called the replica set. So you don't actually interact with replica set directly. You use deployments. So if you're changing a deployment, if you're doing a rollout, if you're doing that is not imperative. That's declarative. You specify what you need, and you have this versioning support. When fails, you can just revert back to the old deployment and all that. So it has that level of sophistication. Mostly you'll be doing deployments and interacting with replica sets. You won't be you won't be interacting with pods directly. You won't be creating pods directly. You'll only be you'll be either creating a replica set and a service, or if you create a deployment, it creates both for you. deployment is pretty much a service plus a replica set. If you're using, there is this tool called kubectl. How many of you have used Kubernetes here? Okay. So there's this tool called kubectl, command line tool, which you use to interact with the Kubernetes API. When you do kubectl space expose either a pod or a replica set, it creates a service and it gives you like an external IP or in your local cluster. I mean, in your cluster. So that's what the expose command does. When you create a deployment, it creates a replica set and it creates the service automatically. You don't have to type 2 commands. So that's the thing about deployments. This thing called stateful sets, like what you have guessed from the name. A stateful set would, like I said a few minutes ago, containers are stateless, right? You store the state outside the container. But what if you want to run stateful apps, like a database? Would Kubernetes support that? If you do a replica set, it doesn't support. But if you do a stateful set, you can you can do something called a persistent volume claim. It has drivers for various stuff like elastic block storage and storage and all that stuff, and even your Ceph file system, Cinder, and all that stuff that you run inside your cluster. You have all that, and you can specify that as your persistent volume claim. And the stateful set would inside the pod, it can interact with the outside volume as if it's your internal volume. So like you can store data, and even if the pod goes down, it stays persistent. And then you have daemon sets. Okay, so when you schedule pods, I mean, when the kube's master schedules pods, see that a set pod will be scheduled to a certain node, right? But there are some activities for which you need a certain pod in all the nodes, right? There is this thing called, I mean, there is heartbeat checking. I mean health checks, and you need at least one pod in all the nodes that are connected, that are in the cluster. So what you do in that case is that you create a daemon set. A daemon set would create one pod per node, and it will schedule it across all the nodes. So that's how you ensure that a pod stays on a node. So what did I miss? Okay. A job is like what Mesos job is, right? It's not a long running process. It's the stuff that you want. It's the stuff that you would do with Kronos in Mesos. The stuff that you want to like periodically execute, and the stuff that you like want to do cleanups and stuff like that. This is the thing that scares many people away. How to set up Kubernetes. It's a nightmare. No, don't try it. Don't try to manually set up it. You have these various tools. Like if you want a local Kubernetes cluster inside your machine, you use something called Minikube. I'll show you Minikube. I have one. The thing about Minikube is that if I start it now, it will be up for the demo. Okay, so we'll see that when it gets started. So there is this thing called Minikube. What it does is it creates a virtual machine, right? It pretty much does the same thing. It creates it actually uses the same virtual machine, to be honest, and it creates the Docker like mobile Linux virtual machine. It's not the same virtual machine. The old virtual machine that Docker used to have, like it's a busy box. It creates that virtual machine, and then it installs all the Kubernetes specific stuff inside it, and then it gives you like it sets up the kubectl to match the local Kubernetes cluster that you're having. So that's what this Minikube does. This is really very straightforward. You have like 4 or 5 commands. It start, stop, and create and update and all that. And then you have this Juju, which many of you have maybe used. And Canonical has its own distribution of Kubernetes. Like since Kubernetes has single binary like Docker Swarm, right? It has various different binaries. Like you have kubelet, then you have etcd, you have kubemaster, then you have then you need stuff for the certificate authorities and all that. So Canonical has packaged all that together using their stuff, and then using Juju you can deploy to let's say all the stuff that Docker machine supports, like DigitalOcean. I don't think it supports DigitalOcean. It supports Azure Cloud, Google Compute, and what's Amazon Web Services and all that. There's this other thing called Cargo, which is basically also if you're using Juju, you can also deploy the normal Kubernetes, which is like Google's, CNCF's version of Kubernetes. You can also use that. People normally do canonical distribution of Kubernetes with Juju. There is this thing called Cargo, which is essentially Ansible, a wrapper around Ansible to deploy Kubernetes on various machines. Then there's this new tool called KOps. All these tools like this, all these 4 tools are from this project called Kubernetes Incubator. The people behind Kubernetes, they understand that it's a nightmare to scale Kubernetes, and so they are developing various projects simultaneously to facilitate the process. So one of these things are eventually going to pick up, take off. So this KOps thing lets you schedule. It lets you deploy Kubernetes clusters inside to AWS or Google Cloud and all that. HashiCorp about it. It's like infrastructure as code stuff. You specify what you need and all your DigitalOcean. If you're using DigitalOcean, your API and the secrets and all that you specify inside a file. And if you do a Terraform space that file, it creates the instances with a set image, and it installs Kubernetes and all that. There is a Terraform file for Kubernetes. So it creates all that stuff for you. Then there is this thing called Bootkube. What it does is it creates a self-contained Kubernetes cluster, which you can then use to connect more nodes, right? If you have a Kubernetes cluster inside a single node, attaching more nodes is a lot easier. All you have to do is you need to go specify a 2-line thing in other kubelets. So this is like your boot BIOS stuff in your laptops, but for the data center. Or if you are like fed up with all this stuff, you can just use the Google Container Engine, which gives you Kubernetes. Okay, so how to use Kubernetes? Or you use the REST API that Kubernetes provides you. You can post, if you're using kubectl, you can specify what you need in a YAML file, like you do with Docker Compose. And if you do kubectl space create -f and the file name, it creates all the pods, services, and all that. There's the specification for what a pod and what a service should have. All that stuff. That's not the kind of stuff that you would want to store inside your mind. You can just copy paste and replace. And then Kubernetes API takes in JSON post requests, and you can if you have it has various access control things, and if you post JSON files, it can create pods and services for you. Okay, let's get back to what a container orchestrator does. It creates, it manages resources, which is a node, and it schedules tasks in the form of quads. It monitors tasks. You have tools like Prometheus for that, and it gives you a way to manage tasks. Just kubectl and the API, right? But what does your operating system kernel do? It manages resources. You have CPU, we have memory. It manages the resources. Then it schedules tasks. You have a lot of these processes and all that stuff that needs to be scheduled. Then it monitors the tasks, and if something goes wrong, it either starts it back or does all that kind of stuff. Then it gives you a way to manage the tasks, the shell and sig in term and all that stuff. So it gives you the same thing, right? What the operating system kernel does, a container orchestrator also does. That's the reason there is this quote from this book called Data Center as a Computer. After specifying various things on how to design a data center, they conclude that we must treat the data center itself as one massive warehouse scale computer. So that's how they do stuff at Google. So this Borg master at Google, and since Kubernetes is based off of Borg and Omega, Borg master is the kernel. So naturally, Kubernetes is the kernel of the data center. Kubernetes inside a VM, it's incredibly wasteful. You need to be running Kubernetes directly on the directly on the hardware on your data center. The reason is, when I said this last time, people asked me a lot of questions, right? How many of you were there the last time, when I was presenting? Yeah. So when I said this, people were like, what would you do if your application wants 2 physics core machine? How would you do that without, if I run it on AWS, if I run my stuff on AWS and I need a 2 physics core machine, I can ask AWS for a 2 physics core machine. But if I'm using my own hardware, how can I do that? But the thing is, the 2 physics core machine is your application's requirement, right? Application that requires 2 physics core machine. And in that case, even Amazon doesn't actually maintain 2 physics core machines. It only gives you a virtual machine that has 2 physics cores, 2 physics V cores, to be honest. 2 physics V cores, to be honest. So what you do is you use KVM to create 2 physics core virtual machines, put your application inside it, entire stuff inside a container, and deploy that container. That's how you do it. So what you need to stop doing is, if you have on-prem infrastructure right now, what you need to start doing is, you need to abandon OpenStack and start running Kubernetes directly on bare metal. The only, you don't have any design problems with it. The only concern would be about the security of this whole Linux container thing, because Kubernetes is, virtual machines are inherently more secure, right? Since they have this whole layer called hypervisor. Even if a rogue process somehow manages to escape the machine, it will only attack that specific machine, right? But when you're using containers directly, you'll have all this thing to, you'll have to, if a process escapes the container, it can pretty much affect every single container. A few months ago, there used to be this issue where if you run a Docker container in a privileged mode, inside the container, if it escapes the container, it'll also have root powers outside the container. So you have only security issues, but really the brightest minds in the city, the brightest minds in the world, are working to harden the Linux kernel. There is this whole movement called hardening Linux. So pretty soon, faster than you can go home from here in the traffic. So Kubernetes is the kernel. So with that thought in mind, I present to you something that I built over the weekend. If you're going to buy my story that Kubernetes is the kernel of the data center, then Podder intends to be the shell with which you interact with that kernel. Or if you don't buy that story, it's just a rudimentary pass that I built over the weekend. Or like you can call my bluff into it. What it does is it can deploy self-contained Golang binaries. For those of you who work with Golang, how many of you are Gophers? Anybody, any Gophers here? Nobody. Okay. So Go, as you all know, is a compiled language. If you get a single binary, you don't have to deal with all this JVM and all that stuff, right? So the thing about using a runtime like JVM or Python or Ruby is, even if you're not using certain parts of that runtime, you still need to have that installed in your machine, right? This becomes when you have a machine that has multiple services, eventually one of those services would need that, and it won't be an issue. But when you're running microservices, you know exactly what your service is going to need. So for every microservice, if you need to install a 800 MB, 800 megabyte runtime, it's going to be incredibly wasteful. Your application is only going to be 5 megabytes. Runtime far exceeds this whole thing, this whole container size. So if you're using Golang or any other statically compiled language, you can have self-contained binaries. This binary has only the stuff that you need from the runtime in case of Golang. So if you're not using HTTP, it won't have any HTTP stuff in it. So the binary will be incredibly small, and it will work depending on which platform that depending on the platform that you compile to. It'll work anywhere, pretty much anywhere. So what if, like, if you still want to use Kubernetes, you'll have to put that binary inside a container and push that to the Docker registry, and then pull it again from Docker registry, kubelet with it. It's a lot of work, right? So I created this thing called Podder. What it does is it gives you an interface. You can just drag drop your binary inside that box, and it automatically creates a replica set. It exposes a service. It gives you the address, and then you can use that address to access that service. All of it. It's just as fast as the binary can get uploaded to the object store. So we'll have a short demo, if God wills it, of course, because you know about live demos. Okay, Minikube has started finally. So this is the kubectl. I hope everybody can see this. Can you read the stuff? You have kubectl. You can do kubectl get pods. And since I don't have any pods, it says no pods. Like I said, here's file. What did I say? Okay. Here's the Kubernetes file. I mean, here's the YAML file that creates a pod, right? The pod has some metadata, which is a name and label and stuff, and it has a spec. The spec is the central part of the pod. The pod, it specifies which image that it needs to pull from the Docker Hub to create that pod, and which port to expose. The product that I'm demoing right now is an extrasol.podder at Docker Hub. But since I'll be using a local database, I'm not going to create this pod. I have a Postgres instance. I'll be running it locally, but still I'll be able to demonstrate. So I'm first starting my Postgres container, which resides inside my machine. So while that starts, does anybody have any questions so far? Because it's self-contained, right? It can pretty much run any binary. Like, no, that's not what I mean. It's a binary, right? It's not limited to, but it's like kind of nice to say Golang, right? People would ask why Golang, and then you can have this whole rant about Java. Yes, it can support something that's not HTTP. But then it would only expose. I mean, it's for simple stuff, right? Service. I mean, it only exposes a service with node port. So it only makes sense if you have a HTTP stuff.
Do you plan to do anything with, let's say, a command line application? Some wrapper over it which will show the output of the command.
Yes, we can actually, like, that should be a separate thing, right? Apart from Quarter. Yeah, we can actually do that.
The use case.
The use case is mostly like what you would do with Heroku. Like you have an external database that you connect to, like MongoLab or something like externally hosted database, and then you have only like the stateless application that's running inside your service. So that's what you do. I mean, like if you upload your binary to this, it gives you a address case, just a node port, and you can use that node port to like access that application. And if you store any data, it will go to the external database. Okay, so this is the app. First, we need to log in. Okay, I have an account called Watch of the Jungle, and I'm entering the password. So when I press launch, it's supposed to like I have this dummy Go binary called fancy host. Okay, the God doesn't will it. I don't think we have enough space. Okay, let's try it again. We'll try it in Firefox. Okay, so first,
Localhost. The second L is missing.
so we logged in. So I have this binary called fancy host. What it does is the binary reads the host name from the OS, and then it creates a hash from the thing. Okay, I didn't start Kubernetes at all. Okay, so what it does is it takes the OS host name, it creates a hash, and since hash is like only hexadecimal, right? If you take the first 6 digits of the hexadecimal, what do you get? You get like the RBG values, right? You can use that to set the background. So I have this fancy host at port 322.322.5. I'm going to run it. So this IP address, which is 192.168.99.100. So what's the address again? Okay. So the color is dynamically set by which host name it is. So since we have like when I uploaded the binary, the podder app created a replica set with 3 nodes. I mean 3 pods. So when I refresh this, we can 1 in 5 times go to a different pod, and depending on which pod it goes to, the background gets changed. So we have 3 different backgrounds, implying that every time the request is going to a different pod. So that would be it.
Is this specific algorithm to which pod it should point to, or
no? Kubernetes does this round robin scheduling, right? Between different, load balancing between different pods, right? Request first time, the second pod the second time, and the third pod the third time. So every time it goes to a different pod, the background changes because of the way I've designed the page. It generates the background color from the host name. So you can actually, I publish all the code on GitHub. I'll post the links. So this is my Twitter. Like I don't actually tweet. So the link, my GitHub address is github.com/extrasalt. Was at the beginning. This will be my GitHub. You have both the source code for the fancy host app and the podder app, and you can run it yourself. Postgres container running, you can run it, and Kubernetes Minikube installed. You can actually run it locally, or if you have an external external Kubernetes cluster, you can like modify the source code a tiny bit to make it work with your external Kubernetes cluster. So that will be it. Does anybody have any questions? Sorry? You want resources to learn Kubernetes? If you want to learn Kubernetes, the best resource is Kubernetes docs, because there aren't any good free resources. Then there is this book called Kubernetes Up and Running, I guess. I'm not really sure about the name. No, the book has been released. It's by Kelsey Hightower. You can
go to datacoder.com, so where you will get all the scenarios.
yes, that's all that is in the Kubernetes docs. You click getting started page, you get all that workshop thing, Kubernetes workshop. So
how is the load balance system?
My thing, or you have like when you expose a service in Kubernetes, you can specify a node port or an external load balancer or an internal load balancer. Okay, there's another thing. Okay, so if you have an external load balancer like you get from Amazon and DigitalOcean, you can use that to route traffic to your pods. To the pods. The service is specific to the pods. Right? So the pod has an internal IP. Each pod gets its own IP. These pods that I just showed you, we have 3 pods, right? One of the pods is 10.0.0.1, the other is 10.0.2, and the other is 3. So you have different pods. So the external load balancer actually directs the request to the pod, not the host. I mean, through the host.
What of service?
Yes, the service. Yes, you have to. The pods are selected for every service. The pod selects. The service selects the pods based on a selector condition. Labels. Yes.
We need to specify the service for that.
Yeah. No, when you are creating a service, you specify that you use an external load balancer. So that way, it's not called internal load balancer. It's called something else. So
it's a called
basically proxy. There is no load balancing internally. A service with proxy request onto all the ports that we gave as a selector. Basically, this service selector backend, app backend. Any port which has this label will get request from the service. It is proxy.
okay.
Add me to the comment. Right? Can you add me?
Yeah, there is one more session.
There's one more talk.
Yeah, there is one more talk. Please stay.
Okay. It's about a real-world production Kubernetes application that we have been working on for last 1.5 years.
All different.
I'm Shahid. I'm from Hasuda. Has anybody heard about that? So what I'm going to talk about now is how we use Docker and Kubernetes to build a PaaS, so platform as a service, along with the backend as a service. So from our friends at Freshdesk, we saw a demo of we saw how they used Amazon's application. So when you look at a PaaS, there are certain direct advantages that you're getting. So one of them is you need not worry about infrastructure. Position VMs, install your software on them, then start copying your application code, then start running them. So this entire layer is taken off. You're directly using certain cloud providers APIs for this. So this in turn enable you to work on your application more, iterate your code, and deploy faster. So another another advantage that you're getting is scalability. You can directly say Amazon ECS or Google, just directly say I need more resources for this application, and it's directly provisioned from the cloud provider itself. You are again not dealing with the infrastructure. Reproducibility also. Let's say one thing goes down, bring it up again without much of an effort. Dig your old disk backups and put it again. But even with all these advantages, there are a couple of issues with most common PaaS that we see. What happens is vendor login. So let's say in case of somebody who uses ECS, they can't move to Microsoft Azure APIs tomorrow. They can't use Google Compute APIs tomorrow. It needs time and investment and man-hours from your team side to learn the current PaaS environment and deploy your application onto it. Moving away from it is not an easy task. So that also limits you in terms of flexibility. If you're using AWS, you're limited to AWS's services and APIs it provides. So if you need something that recently launched intelligence APIs, you can't easily use it from an AWS perspective. Different API convention, everything. So it again takes time for you to learn these things and apply it in production. And there's a single point of failure now. If AWS goes, what happens? We also, right? February 28th, most of the internet was out. Why? Only because their S3 service was down. And the service dashboard depended on S3 service, which didn't even show that S3 was down. So these are the kind of issues that we try to address when we thought of building a PaaS. So the solution is a PaaS that can run any application you want, and that is where Docker comes into the picture, and which works everywhere. AWS, Google Compute, Microsoft Azure, DigitalOcean, bare metal, your local system, anywhere and everywhere you name it, it should be able to run. Kubernetes come into the picture. So when you look at Docker lets you package your dependencies and code together. So it is portable, you can run it anywhere, and it lets you version your deployments, it lets you scale your application very easily. So this is what a bunch of solutions that Docker bring into the picture. Now, when you look at Kubernetes, before that, there are a couple of issues that comes with Docker. When you
do something with using Docker, you need to take care of the configuration, file mounts, logging, port mapping, and the file mounting. Architecture, you have to think a little differently. Your DevOps team have to think a little differently. So a couple of these problems, Kubernetes container orchestrator like Kubernetes will solve. So Kubernetes will look at your entire infrastructure as resources, CPU, RAM, and disk. Come into the picture because most of the services are stateless. CPU and disk, RAM is the most important resources here. You have 10 1 GB 3-core VMs. You add them to Kubernetes cluster. Suddenly you have a 10-core 30 GB cluster available for your application workloads. It also manages the container, as Mohan explained, manages the containers. It makes sure everything is running fine. So as you mentioned, deploying it can work on any infrastructure, but deploying it is difficult. And there are hosted Kubernetes platforms like GKE, Azure Container Service recently launched Kubernetes on top of it. So there is Tectonic by CoreOS. So this is what a overall architecture of Kubernetes system looks like. World where is the internet, and there will be a firewall or a load balancer, and you have a couple of nodes which is part of the Kubernetes cluster, and on top of it there is a Kubernetes overlay network. Now this network takes care of everything happening inside the Kubernetes cluster. There are several pods running. There are some pods are just starting to just starting up, some are terminating. The pods behind a service will make sure that you have your requests are routed to a running pod always. Let's say you set replica is 3. 2 pods are starting up. There's always one working there, right? So that makes sure that there will not be any request that is not gone served. So this is a typical architecture of a servers. The pod could be a database. The load balancer can be anything from your cloud provider. It could be a AWS load balancer, Azure load balancer, or Google GC load balancer. The nodes? It can be anything. Since Kubernetes work on any infrastructure, it can be EC2 instances, it can be VMs on Azure, it can be VMs on Google Cloud, it can be your local machine, couple of machines in your office. It can be anything. In that case, you will have to take care of load balancer yourself. If it is in a cloud environment, this load balancer comes with the cloud environment itself. So what Hasura is a Postgres backend as a system and a Kubernetes platform, backend as a service and a Kubernetes platform as a service. So you can think of it like Parse and Heroku together on your own infrastructure. I've used Parse, good old Parse. Heroku, most of us are still using Heroku. So technically, Hasura is nothing but a plugin to Kubernetes. Wherever you have Kubernetes running, you can have Hasura running. So this plugin is written in Haskell. So it's just a compiled binary, which is very small, 5 MB something. And on top of it, you get data and authentication APIs out of the box. This data component is again written in Haskell. Authentication component is written in, it's just a Django modification. Now you get certain features like deploy with gate, API gateway with free SSL. So I'll come to these things. So first thing, since it's a PaaS, you need to be able to deploy any application you want. So Kubernetes can run Docker containers natively. You can also support RKT containers, and LXC containers are in development. So since Kubernetes can run any Docker container, provide a UI on top of it for you to run any Docker container you want on the Kubernetes cluster that you have. So you just need to give a subdomain name. So what we make sure is through our gateway, we route to every container, not through a port. The port is exposed only internal to a cluster. Every container's routing is done through a subdomain. So let's say you have an API service running. It's called API.your project, something booking.com. And you have another static server running for serving image files. It could be something like static.project.com. So it lets you add all the environment variables, your Docker image, its credentials, and what port you need to expose, and whether you need to have data persistence or not. What in turn it does is it creates all this Kubernetes objects in the background. Creates a deployment for deploying the Docker container or the container. So it creates config maps to store your environment variables. It creates secrets to store your Docker credentials. It creates a stateful set to store your stateful application if you need data persistent enabled. It creates persistent volumes and persistent volume claims so that you can use the cloud provider's native storage support. So if it is an AWS, it can use the EBS storage directly to store your database files. So that's about deploying any Docker image that you have right now. Now you don't really need to have a Docker image. All you need to have is a Git repository with a Docker file in it. So basically, we are not adding any layer on top of it. We're just giving easy way of using these things. Tell you what you do. You have a Docker file. Push the image to somewhere, and then you specify the image somewhere. It will pull the image. Instead, we are just pushing the Git repository. We have a Git container running, which is basically an SSH container that will receive the Git repo contents. There's a Git hook in that container, which will do a Docker build. Whenever a push is happening, it will invoke a Docker build. It will push the image to a local registry, and then when it will also deploy a Kubernetes deployment and service. It will roll out a Kubernetes deployment and service. Now the advantage here, what you get is, if any of the step in your Docker file or the deployment fails, your push fails. So you are like guaranteed that your stuff will work if your push has been succeeded. So that's one easy way to use Docker images. You can get out-of-the-box Docker files, anything in the website. So another factor is the API gateway. Since Docker containers only way of communication is using ports, it's very inconvenient, right? You have a website, and then you have a API that powers the website. The website is hosted at www.website.com, and your API gateway, it looks really bad, right? When you're making a request into website.com:8080. So instead, we thought subdomains are a better way of abstracting services. So yeah, so that your www website can call api.website.com in the API calls. So the API gateway is nothing but an Nginx container, which is scripted using Lua, and so the container is called, the build is called OpenResty, which is just Nginx and certain Lua APIs included. So what it does is it routes to the correct service. You say API, it picks up the correct service from the Kubernetes directory, and then it routes it to the service will route it to the correct port. So now one important thing is that so this is by default. So the gateway is the only way to enter your cluster, enter inside a Kubernetes cluster. That we believe in very strong security principles. So only ports exposed are 80, 443, and 22. So you have HTTP that will be redirected to HTTPS. Then you have 22 for SSH. So the gateway, depending on the subdomain, it routes to each service that is running. Now this becomes a microservice platform. It has tight integration with authentication and authorization. So the gateway itself is who is the authenticated user? Is he allowed to access the service? If based on that, it will add these two headers. And now when you have a custom API running, all your API need to take care is these two headers. Gateway will add these headers, and depending on this, your API can take actions. you need not look up a database again and then decide whether to allow this action or not. The action only come to your thing only if it is allowed to come. So this is what the session. Yeah, so the middleware is part of the API gateway. It looks up a Redis data store for tokens. So basically, when you log in, a token or a cookie is set based on if you have a cookie capability or not. Yes, this cookie or the token is resolved data store. So whenever you log in, the authentication service will put one token into Redis. If the token is present, API gateway will allow you. So this using Redis will make sure that you have fast lookups. So that
So this is still purely web based because you're checking up from the cookie, not from the backend. If I want to check the API gateway that you have, how does it authenticate if I give a call from backend?
So from the backend means inside the system, inside this system itself.
No, if I do a call from a backend.
Yeah, you have a token-based authentication also. That serves the purpose, no? So cookies for browsers. It checks if the client has cookie capability, then it will set a cookie. Otherwise, you can always request that authorization bearer token.
Okay.
You can always use that header. So if you have cookies, you can use that header and it will work. So for services inside the cluster itself, you don't need to set cookie or anything. All you need to do is set those two headers and it will be carried over directly. By default, there are anonymous roles and these things are taken care of by the gateway. So now there is data and authentication APIs. So data is just a GraphQL-like API, just an API over Postgres database. So you have all the advantages of your relational database, plus you have a MongoDB-like querying structure to that. Supported by raw and column level permissions. What that means is that you can set what user with what user ID or role can access each row or each column in the database. This is not something that you have directly with a vanilla Postgres installation. This is made possible using our own wrapper over Postgres, which is also written in Haskell again. So we have a couple of big fans of Haskell in our company. So which has actually proven benchmarks over Firebase or Heroku or bare metal installation. You can go to that link and look at the benchmarks. So the authentication service takes care of login, registration, OTP, email verification, all these things. So it's a Django modification. Now, to access, let's say you want to access your Postgres directly. So since the only ports exposed are 22, 40, 443, and 80, what you need to do is, as we believe strongly in security, we don't want you to expose your port 5432 at all, which is the default Postgres port. Now, even if you're exposing it, you need to secure it using TLS. These are extra headache, right? Two is to make an SSH tunnel to the SSH container, and from there you can connect to Postgres. So basically, your local port 5432, you can map to the Postgres 5432 securely over SSH. So this is what you do if you need to directly connect to any secure service that is running in your cluster. So that's about it. You can take a look at our website, and there is a 5-minute demo also. You can go look at it, and it will let you also host any kind of website, any Docker image you have. If it is a web service, you can host it on the Hasura platform. Now, any Kubernetes installation you have, you can install Hasura platform on that. So right now, it's we haven't open sourced all the components yet, but technically you can install it on your local machine with you. We are in process of documenting everything and putting out everything. So it's free to install and free to use on all the all single node applications. So our main objective is to power real world applications in multi-node environments. So for that, you can check out the website and see the application notes on it. So this will take you through deploying a simple blog, how you do it, and you will be given a console using which you can log in and deploy a blog, let's say Ghost or any other platform, blog, WordPress or anything. There are certain quick start templates available, which is just a curated list of proper Docker files and everything for all kind of open applications. This. So this is just a. What I want to highlight is the technical problems that we faced with a normal pass or anybody, and how we try to solve it. You can take a look at the demo on your own. So yeah, the main point is that pass is obviously convenient, but there are certain problems that comes across with it, especially the vendor lock-in, and that is where we try to solve the problem. And when you use containers, all these messy things with ports and hostnames will come into the picture, and that's another problem we try to tackle. And certain things like database and user management, everybody needs, and we try to include in the PaaS offering as well. So that's about what Hasura is. How good is? That integration with I didn't get you.
You're binding a
ZMQ. So you need to have a certain messaging for your application. Let's say your application stack.
You can bind as a service in your
So what you're saying is your application needs a messaging queue for it to run, right? So you can directly put it as whatever your application need. So we don't give you a messaging queue as it is, but if your application demands it, you can always add it as a Docker container.
So are there any features for the migrating from one service provider to the other?
We have a rudimentary migration for parse, but apart from that, if you have a Postgres database, if your application has a Postgres database,
I ignore about the traditional database, like other control the storage like S3 and Azure.
So we don't have specific migration guides ready, but we'll be happy to help you on a case-by-case basis. We have to look at your application and then decide.
Okay.
So we don't have ready-made migrations ready for anything apart from. But the point is that any SQL-based database, you can directly put it into the platform and you have a ready-made API. And the API is very powerful, so that because it gives you raw column level permissions and everything. You will not have to write your backend code at all. The platform, people who have used parse will know it, but then there are certain problems with parse also. It will not let you create relationships in a very nice manner, or foreign key or many-to-many relationship. The solutions are all not very nice. So any other infrastructure related questions?
How do you separate containers of one user from the containers of the other user?
So every container, your container run in your infrastructure. You log into Hasura, you give your DigitalOcean API key, we create a VM, we install Kubernetes on it, and we install Hasura on it. So everything is with you. We don't do multi-tenant system. So your infrastructure is hosting everything. Nothing is with us. So Postgres is yours, the data is yours, everything is with you. So Hasura is also one way of installing Kubernetes machines on cloud provider actually. So you can install directly in AWS, GC, Azure, and DO from a website directly.
If I install Hasura, it sets up Kubernetes for me.
So what happens is that if you provision, let's say in case of DO, let's say you give a DO API token, a DO instance with a cloud config file, which will set up the Kubernetes instance. Complete, we will make a Kubernetes API call to install Hasura. So installing Hasura is just creating one deployment on top of Kubernetes, which is the plugin that we call. So that's how it happens. Yeah. Any other questions? No. Thank you.
Okay.
Thank you so much.
Thanks for everyone to present, to coming and make it a thing. And actually, it would happen in starting of the session. So we are working a part of AstraZeneca application development. AstraZeneca, it's a global leading pharmaceutical company. This global technology center, we are AstraZeneca R&D and finance and operation and other all the activities. So we have a meetup group, Chennai DevOps Meetup. This is our 14th session. So we are last 1 year we are conducting this session. And thanks for Sahit and Mohan and Akhilesh and Subhas to make this session. And we have organizers from Press Desk also. There's Sam. So thanks to everyone. We are arranging the lunch over there in pantry. Please help yours. Thank you.
Thank you.
We have something. Mohan. Akhilesh.